So while other people are joining, let's slowly start. So nice to see everybody who joined us. Already I see here people from 5 countries, and I'm glad to see you here. Hope others will join us as well. So just a few hours ago, I must say, we had a webinar on the same topic, but in Russian language, which gathered nearly 80 another people from other 8 countries. So the topic is the second in our series of Healthy Land webinar. The first one was 2 weeks ago about the biofertilizers and actually situation on the fertilizers market. So if you are interested, there is a recording on our Facebook page or on YouTube, so you can write us a request, we can share it with you as well. So today we will talk about another topic. We will talk about the seeds and tools to improve their germination and to improve the root system, growth, etc. So we will talk about different kinds of inoculants with a focus on inoculants for legumes, like known like rhizobium strains, and also about the mycorrhiza. So to start with, just to remind in a few words about BTU Center. BTU Center is a Ukrainian company, a producer of microbial products for agriculture. Below the slide, you can see our brand, and it reflects the philosophy of our company, Żywa Zemля in Ukrainian, and in some Slovenian language, it sounds similar. In English, it's Healthy Land. And again, it's our philosophy to do something, to develop our business towards implementation biological solutions which improve health of environment and health of soil. So we do that by producing and introducing biofertilizers, biostimulants, microbials for soil health, biopesticides, etc. And we implement them in integrated technologies as well as in organic ones. Concerning the popularization of this philosophy, we do a lot of educational things. For example, course of simply about microbes with our microbiologist who tell in simple words about quite difficult processes which take place in the soil or during agrocenosis of different plants growing. Just give me a second and I will close the window for you to hear me better. So I'm here again. So to continue, BTU is a group of companies. We do we do business in different spheres. The main one is agriculture, and here we have more than 60 products. Most of them are certified in organic agriculture. Currently, we are present in 18 countries, and also we implement or provide access to the biologicals not only for farmers but also to just people who have some plots near their homes, and this is our proud also to be represented in this sphere. Besides that, we are proud to have an Institute of Applied Biotechnology. This is a private entity, laboratories with nearly 20 scientists gathered to answer difficult questions which we have from our partners or clients, to do some diagnosis, to do R&D and tests and trials, to know everything, to be ready to answer the most difficult questions. So company has more than 400 people, can produce 10,000 tons of microbials per year. Products are used on 4 million hectares. And another important thing is that we do thousands of trials to prove every claim of our products, which we give to them. So coming closer to our topic of today, we will talk about some tendencies of legumes growth, and which is the main market for inoculants, especially symbiotic ones. So why legumes are in trend as well, and why areas for legumes growing will increase, is because legumes actually are the good alternative for alternative source of protein to change some part of the animal origin protein, because no, it's a protein which is needed by human to I would say to survive, and but besides this main source of nutrition for us, if people eat legume-based protein, it also has some good influence on people's health. Like it has decreased cholesterol amount in the body, and etc. Besides that, legumes, when they are grown on the soil, they prevent soil degradation. They also fixate nitrogen and increase amount of nitrogen available in the soil. And thus, it is recommended to have legume crops in field, not less than 20% in a rotation of the farm. And it's known fact that, not fact, but known prognosis that as population will increase rapidly during nearest, during nearest future, and that is why people will need more food, more protein to survive and have normal nutrition. And again, legumes are projected to be more important source of people's protein. And in some interesting data is below in the below part of the slide, that legume crops require much less water than, for example, chicken growing. And it's very important also because water is another raw material or resource which is limited on the earth, and which is projected to have some limitations or problems in the future. In some countries, there is already such a deficit of problems with fresh water. So changing of sources of protein and nutrition to those which require less water for production is could be a solution for, or part of the solution of this problem. And another interesting thing is the carbon footprint of protein, of the pulses protein, pulses or legumes, because if we compare, for example, beef or some other sources of protein of animal origin, like cheese, milk, pig meat, or fish, even eggs, we can see that it is all the time much more bigger than emissions of greenhouses in production of pulses or legumes. So again, legumes growing addresses several global problems like green gases, like protein source, etc. That is why it will increase the areas of growing with legumes. And here is some world statistics about the growing of here as a soybeans, but also you can use this source USDA report to see the analytics for growing of another crops. But what is important about legumes, and on the example of soybeans, that we can see that in comparison to previous year in the world, the areas with legumes is increasing, not so much, it's like 1.3%, but still it's a growth. And you can see more or less how it changed in the world. For example, it's interesting to mention that in Ukraine, more or less, it's expected even less than the previous year, but in some countries, it is expected to have some increase. Another interesting and important thing is a projection of yield of soybeans in the world and in regions, because, for example, in the world, you can see that during last months it even decreased this projection. That average yield in the world of soybeans will decrease for 1.7%, which in total will give us less production of soybeans in the end of the year. And but for example, in some countries, for example, in Ukraine, it is projected that the yield of soybeans will increase. My hypothesis is that production of and the yield projection is connected with the availability of nutrients in different countries, in different regions. Ukraine has some producers of nitrogen fertilizers. That is why maybe the yield projected in Ukraine is better. Or I don't know which actually factors this organization take into account, but I'm sure that it's quite a serious and comprehensive thing. Also about the global factors, again, I also already mentioned the situation on the fertilizers market. If you would like to hear more analytics about this, you can address our previous webinar where we looked on different factors which influence the market and some projections. But still, this deficit and the prices of NPK also change the behavior of farmers in like all regions. My opinion is that this deficit and prices also will increase interest of farmers in growing of legume crops and soybeans, because it is like probably for their field it is an additional source of nitrogen for the future. That is why, again, in conditions of very costly nitrogen fertilizers and in conditions of good prices for legumes, probably areas of legumes growing will increase this year. And also important thing are the logistics risks and logistics change, because again, because prices for legumes are now quite high, and there could be some restrictions, again, availability of nutrients, and some markets also change policies. For example, here is that India is more opening its borders to import legumes. All these things could change the chains of legumes, I would say, movement via the regions of the world. But coming closer to our topic, we will talk more about inoculation. And inoculation is not only about the Rhizobium bacteria, but it is used for connecting all mainly microbial products which are used for seed treatment, and with different reasons. One of the reasons is actually improvement of nodules formation for nitrogen fixation. Second reason could be mycorrhization of the roots and improving making bigger the zone of root zone, which can absorb more nutrients and water by plants. And there are also some universal inoculants which are not specific to the plants but can work with different. And actually, I must say that mycorrhiza are not universal at all, but are quite universal, because there are only some crops which mycorrhiza cannot form symbiosis with, but mainly most of raw crops and some fruit as well, berries can make this symbiosis. And talking about Rhizobium, of course, this is the situation when really these strains are specific, and for each kind of legume crops you need a separate strain which is symbiotic to the crop. Here is some analytics about the markets of inoculants and mycorrhizal products, and I will start from the right part. No, and it is obvious that the regional distribution of legumes growth, beans growth, is correlated with regional distribution of inoculants. So, of course, countries which grow more legumes use more inoculants. Talking about the inoculants, it's quite a traditional market, and I now talk about the rhizobium inoculants. It's a traditional market which is like more or less 100 years old. And now you will not surprise any farmer if you talk him to use rhizobium inoculants for growth of legumes, because again, it's known, and there is quite a lot of data and let's say knowledge for use of this kind of products on legumes. So mainly the question is which inoculant to use, but not if you use inoculant or not. That is why market is quite mature already, but still there are some growth projections during next years, and it is quite correlated again with projections for increase of area of legumes growth. If we talk about the mycorrhiza market, it's I cannot say that it is less old, but now it is coming quite popular, and even on like international events of industry of biologicals, mycorrhiza is always like one of the main topics, and it is growing, and people are more and more interested in it. Scientists discover new and new possibilities of mycorrhiza, for example, improving heat resistance of plants, and etc. That is why the speed growth of this market is quicker than inoculants, but still for now it's like more or less 1/3 of market of inoculants if to compare, and in the future we expect this market to grow faster. So what to look on if you are thinking about which inoculant to choose? So here are some general recommendations what to look on. So first thing is titer. It's amount of living microorganisms per 1 milliliter of per 1 cubic centimeter of the product. And why it matters? Because it is one of the main factors, amount of microorganisms which go on one seed, one of the main factors which will influence the amount of nodules you have on your crops. So that is why please check what is on the label, and if you can, please check in the lab what is the real concentration of the product. So second thing is somewhere correlated, because freshness of the product also correlates with the effect of the product in terms of inoculants. Again, because especially for liquid formulations, they have quite a limited shelf life. It can be like half of a year or 1 year. And the more fresh is the product, the more living microorganisms are inside, and the more active they will create symbiosis with your legumes. Third thing is adaptability of the inoculant to different crops. Again, first of all, talking about the rhizobium inoculants. So again, important thing is that each legume crop have symbiotic microorganisms to it. So again, there cannot be a universal tool. There could be, but they probably will be less effective. And do not use inoculant for peas on soybeans, because result will be not so good as you expect. So another thing is convenient formulations. There could be different formulations. We, for example, propose a liquid one and dry, which is used for mixing with seeds in like a seed tank in a sowing machine. So you choose the inoculant. At least when you choose an inoculant, you have in mind what techniques you have, what you don't have, and what will be more easily for you to use when season starts. Price is obvious. and proof of effectiveness in your area or like in your conditions. Another important thing, because something which work perfect in like, I don't know, in Brazil can have another effect in Ukraine. Another thing is registration, because if product is registered in country or in like EU, for example, or in your region, that means that at least there was some procedure, there was some check of safety check. Probably in some countries there is check of biological efficiency. So if you buy product which is registered, that means probably you can have better guarantee for its effects than if it is not. And logistical convenience, again, especially now, time of delivery to countries with C, for example, is increased comparing to previous years. And a lot of inoculants, for example, are imported from Latin America or in other regions. And that means that local companies make some stock of inoculants, and please, how to say, pay attention that you have a source where to get the inoculant before season start, because when if you make a decision in final say data before sowing, probably you can be left without inoculant, which is not very good. You will not reach a potential of your crop. So in brief, it is all about the introduction. You can find more on our page on Facebook, on our webpage, on Instagram, or on LinkedIn, or on YouTube. And you can use these QR codes to go to that page. And also, I would like to pay attention to our course of Microbe Simply. We have a special course about mycorrhiza, and here our main expert, Volodymyr, tell the mechanics of action of mycorrhiza, some of its history, etc. So it is already available in English, Russian, Ukrainian. We also adapt these videos to another languages like Bulgarian, Romanian, German, and others. So again, if you are interested, we will adapt it to others. I did manage Slovak, I think, in Serbia. So please, if you have time and have another questions about mycorrhiza, you can use this link as a source. So that's all for my introductory presentation. I see here some comments. Okay, so now I will give a word to my colleague, Alexander. Alexander, are you here? And Alexander will tell us about our portfolio and our practice in terms of inoculants for legumes. So again, if you have questions, please write them in the chat, and after each presentation, we will answer them. Alexander, I think you need to.
Can you see the presentation?
Yes, we see. Actually, we do.
Okay, so yeah, hello everyone. My name is Alexander Rontsevich. I'm an agronomist at the International Department of the EU Center. Today I will talk about symbiotic inoculants for legumes crops, efficiency of action, methods of application, and results of field trials. So let's start with a little theory about ways of enriching soil with nitrogen. There are, I would say, there are 4 general ways to see how we can how the nitrogen can go or can be uptake by plants. For example, the first one is electrochemical and photochemical nitrogen fixation by green plants. The second way is to fix the nitrogen by free living bacteria in the soil, like Azotobacter. And the third way is to fix the nitrogen by symbiotic bacteria, which is work well with legumes. And the fourth way is to input the nitrogen by liquid or complex fertilizers, liquid or dry fertilizers. If we just talk about the associative and symbiotic nitrogen fixers, there are a few mainly used bacteria, which is economically effective. And the most important one is Bradyrhizobium japonicum, Rhizobium leguminosarum, the Aspergillum brasiliensis. This bacteria is widely used in inoculants as associative nitrogen fixers and provide nitrogen directly to the plant instead of receiving sugar for their own nutrition. So, on this slide, I will talk about our inoculant called Rhizoline. So this biopreparation is based on a liquid form of biological inoculant, which is used mostly on a day of sowing. The product contains the concentrate of viable cells of noodle bacteria like Bradyrhizobium japonicum. Also, we have products which are focused on other crops. For example, we have a product based on Rhizobium leguminosarum, Fazioli, and Vice. Also, we have a product based on Rhizobium cicero for chickpea and other legumes, together with the biologically active metabolites. So each of these products contains a specific bacteria for a specific crop with other metabolites. So the main effect of application of Rhizoline is to fix the atmospheric nitrogen and transform into accessible for plants form. It intensifies the process of nodulation, provide plants with the growth stimulating substances, and also altogether all these effects increase the yield of soybeans, peas, or other legumes up to 15%. So the general rate of application is from 2 to 3 liters per hectare. If we just treat the seed, or if we use the product when we apply product in the row or in furrow, the dosage, the rate is much lower, is 0.2 to 0.3 liter per hectare. So the titer of the product is 2 multiplied 10 milliard colony units per milliliter. And so the concentration is quite good for this inoculant. And also, I want to focus your attention on the shelf life of the product. We can store it for 6 months at 4 to 10 degrees, and 3 months from 10 to 15 degrees. On this slide, I want to just stop on the methods of application. So we usually recommend to treat the seeds in the day of sowing, and the rate is 2-3 liters per ton of seeds for soya or other legumes. Also, we have a kind of dry form of this inoculant with almost the same rate, like 2 to 3 kilograms per ton of seeds for soya and other legumes. Also, if the farmer has some kind of delays in the sowing process, we even could recommend to treat the seeds 5-7 days before sowing by our product Rhizoline together with adhesive agent liposam with a rate of Rhizoline 2 to 3 liters per ton, and for liposam is 1 liter per ton of seeds. Yes. And then I will talk a little bit about on specific bacteria which we use in our products. I will focus on a few of them, like Bradyrhizobium japonicum is a type of noodle bacteria, saprotrophic nitrogen fixing symbiont of soybean, and this is the most economically important types of bacteria. And other one, which we use for specific crops like Rhizobium leguminosarum phaseoli for different varieties of beans, and also Rhizobium leguminosarum for peas and vice, trifoli, and the bacteria like Rhizobium leguminosarum vice for different varieties of vice, lentils, I mean. Next bacteria like Mesorhizobium cicerii, we recommend to use if you want to inoculate the chickpea. The last bacteria is Synerhizobium meliloti, which we recommend to use when you want to when you grow the cover crops like alfalfa. And yeah, we get a little bit of statistics from our field work. We can say that with the product Rizoline, there are 600,000 hectares of legumes treated. More than 1,000 agro companies have used the inoculant. The average increase to the yield is 0.25 ton per hectare in comparison to the control. And this product is used for more than 10 years, as it shows the stable results every time in different climate conditions. Here is you can see some statistics of results on different crops like peas, soybean, kidney bean, lentil, chickpea. Let's focus, for example, on the chickpea. We have done 28 trials. 89% of them were successful. So the average income dollar per hectare, we see that it starts from 181 for maximum 749, which is quite good to mention because of if we just check the price for chickpea on the market now, so this means the farmers how to say, he pay less for a product and get much from the raw material at the end of the season. Also, some numbers about increase of the yield ton per hectare. We see that on average it starts from 0.3 to more than 1 ton, 300 kilograms per hectare. For example, on this table, we can see that the product was tested during many years in different regions in Ukraine. Of course, also it means different climate conditions, soil conditions. The main methods of application was a seed treatment, and the rate of application did not change too much. It starts from 2 to 3 liter per ton of seeds. And if you just focus on a right column increase ton per hectare, we see that on every year we see the stable increase to the yield in comparison to the control. So it means the product works well every year, and the concentration and the quality of the products is on a high level. Here I will briefly explain the field trials that we have done on soybean. For example, this slide we can see the trial together with the Rizoline with a bioprotective agent Rizosave, together with a combination of chemical protectants, and it gave us the possibility to see that even together with some chemical protectants, we can combine our product and get a good yield, a good increase to the yield in comparison to the control. On this slide, we can see it was just simply tested Rizoline with protective agent Rizosave. This was a trial on soybean, and we can see that in comparison to the control, we we've got a good increase of the yield up to 200 kilograms per ton, up to 200 kilograms per hectare, in comparison to the control with analog product. On this trial, we also tested the Rizaline with a protective agent RizaSave together with a MyCorrhizae in comparison to the control with analog preparations. And here again, we see that the combination of such products gave us increase to the yield up to 300 kilograms per hectare. And also we can see on the pictures the difference in color and the height of the plants in comparison to the control. The next trial of Rizaline is RizaSave together with a chemical protectant show us, we can see there are two controls and two trials spots with a combination of product. And even if we combine biological product with a chemical one, we still have a stable increase to the yield in comparison to the control, which was without any inoculations. Here is more detailed trial of Rizaline, comparison with analog and treatment with chemical preparation TMTD. We can see on the picture that the nodules was created good. So we see the nodules formation during the development phase of first cotyledon leaf. And in case of application of chemicals and products for nutrition like nanovid molybdenum, in this combination, we also have increased the yield in comparison to the control up to 600 kilograms per hectare. And so the products such as TMTD and molybdenum did not suppress the work of inoculant. On the next, on this trial, we see again the Rizaline was combined with a protective agent RizaSave. It was the main crop is soybean. The seeds were treated by our inoculant and chemical protectant in comparison to the control with inoculant analog. And again, this combination gave us the increase to the yield up to 230 kilograms per hectare. And if you just pay attention on the field, we see the difference in color. On the left side of the picture, we see the deep green color, which is show us that the inoculant work well and provide plants with enough amount of nitrogen. This next slide was done in 2020. Here we have an interesting combination of Rizaline together with our PK mobilizator ground fix. This was a trial on soybean, and here there is a difference that the Rizaline was applied in furrow by rate 0.35 liter per hectare, and ground fix was used in pre-sowing tillage with a 5 liter per hectare. This good combination gave us such a good results, like increase to the yield up to 620 kilograms per hectare. So it means that the inoculant can be combined with other biologicals to provide a more good nutrition and an increase to the yield. This trial was done last year in 2021, again on soybean, with a trial design like Rizaline plus RizaSave in comparison to control with inoculant analog. And we also see the difference in color on a picture on the side of trial, the deep green color in comparison to the control, and also we got results like the yield increase up to 200 kilograms per hectare, which is good. which is so us that every year we still have a positive, I would say, feedback from the soil is that the inoculant works well and provide enough nutrition for plants, like soybean. Also, we conducted a few trials abroad, like in Kazakhstan on soybean, and it was also a challenge to see how the Rizaline works at different climate conditions. And we even at climate conditions, we still have an increase to the yield up to 130 kilograms per hectare. Here we applied Rizaline together with our adhesive agent liposome. And on the pictures, you can see the height of the plant, the number of beans formed on the plant. Also, at the trial, together with the trial, we also got another results with other analog inoculant and growth stimulators. So we had different variations, options, how to see, just to check if the application of Rizaline and liposome enough to provide a highest nutrition in comparison to other options like moisture retention, absorbent, analog inoculant, growth stimulator, and together with in comparison to the control side. And we see that the Rizaline with liposome work well and I would say provide enough nutrition and stimulation effect to the plant. We have conducted a trial on soybean in Kyrgyzstan. On these pictures, you can see, especially on a trial site, that the plant is bigger, the root system is much longer, and so the nodules just to begin start to be formed, and the difference in color as well. So the data of this trial will be collected a little bit later, but it's good to see that the product works under the stressful conditions like intensive sunlight. Also, another trial we have conducted in France just to see the efficacy study of Rizaline on chickpea. Here we treated seed of chickpea with the Rizaline and Rizosafe, and compare it to the inoculant analog. Even at in such interesting climate conditions, we've got an increase to the yield of chickpea up to 100 kilograms per hectare. And you maybe can think that this is not a big amount, but if we just check the amount of money which the farmers spend on treatment, and check the price for chickpea, for 1 ton of chickpea on the market, you can understand that the farmer get a very good result and get extra money in comparison to the control side. Just to conclude about Rizaline and its application and recommendations, I want to notice that the treatment of seeds of leguminous crops such as soybean, chickpea, lentils, peas, and beans with Rizaline increases the yield of these crops. The product can be used for press-sowing treatment of seeds. It can be mixed, if it's a dry form, it can be mixed in the seed drill. Also, it can be applied together with the seeds into the row at the sowing time. The product at the rate of 2 liters per ton of seeds consistently increased soybean yield, irrespective of the fertilizer system. The use of Rizaline, the rate of 2 liters per ton of seed treatment technology, can be also combined with other biologicals or chemicals preparation, which is a good point to notice. And but of course, for any specific or particular active ingredient, the best way is to consult with a manufacturer. And also I wanted to say that even with a lower rate of Rizaline when we are applying into the row, the products still show us and provide a stable increase of the yield. Even if we just, even if the product are used in conjunction with other biologicals preparation or liquid complex fertilizers. So thank you for your attention. And if you have any questions, I will try to answer.
Okay. Thank you, Alexander, for the presentation, for a lot of examples on different crops, different conditions, different regions. And while we do not have questions now, I will ask you if you can mention some frequently asked question for Rizaline, for example, one which were asked on our previous webinar today. And while you are reminding, I will comment that Rizaline is one of the first products we registered in the EU, in Germany. So it's also FIBO certified for use in organic farming. We are like collecting EU experience for this product in the EU. In Ukraine, it's also one of the oldest of our products. Also concerning the formulations, we have two formulations, liquid and dry again, and the main let's say argument to choose is convenience to use your technologies. And also there are some sorts that in dry conditions probably dry formulation could be a better choice because of better conditions of for the microbes. So Alexander, do you remember any other frequently asked questions for inoculants?
Especially when, as some of our people who attend in webinars ask about the dry form of Rizaline, and for example, if it's block the sewing machine because of the some coagulation things, or maybe the pieces of peat are too big to just for seeding machine. So the answer was, if you just mixed the product enough just to make the you just simply need to mix product several times to make the solution with of seeds and peat I would say homogeneous, just to make sure that okay, there are not you can just visually check if there are not big parts of the peat in a sewing drill. Then there should be not a problem to simply seed seeds into the soil. Also, we had the questions about if for example, farmer wants to use 300 kilograms of nitrogen together with an inoculant, and he didn't see the development of nodules on the root system, and he asked about what's going on and how you can explain it. So the answer is just because such amount of nitrogen used just to put in the soil cause a toxic effect on a bacteria to form nodules. We do not recommend to use a high dosages of nitrogen together with inoculant, and the suitable amount could be up to 50 kilograms of active ingredient of nitrogen together with for fertilizer together with inoculant. It will be enough to for plants and for bacteria just to grow and work as a symbiotic agent to the legumes crops.
Okay, so thank you again, Alexander. And if there are any other questions, please write them to the chat or to us directly to email, and we are open to answer them. So now let's give a word to our another expert, agronomist Dmitry Chernenko, who will tell us about the mycorrhiza and mycorrhizal product MycoFriend, and some theory and history about mycorrhiza, how it works on different crops, and a lot of examples from our practice. So Dmitry, are you ready for that?
Yes, I'm ready. Thank you. Hi everyone. My name is Dmitro, and I'm agronomist of BTU Center Company. And I need one moment for translate. So today we will discuss topic what is mycorrhiza and why do plants need it, the effect and methods of application, efficiency in the field, and my little topic, it is mycorrhization, a luxury or a necessity. So mycorrhiza development fungi. Mycorrhiza, it is myco from the Latin like mushroom, and rhiza from the Greek like root. And I want to tell about over 80% of plants develop mycorrhiza. Only representatives of the cabbage and amaranth families do not. Mycorrhiza, it is a symbiotic association of fungal mycelium with plant roots in the process of photosynthesis, carbohydrates, and accumulated in the roots of plants, and the plant shares them with the fungus. In turn, the fungus colonizing the roots acts as an intermediary between the plant and the soil. When growing the mycelium is able to increase the volume of the total absorbing surface of the root thousands of times. And how is mycorrhiza formed? First step, it is germination spores. Second step, it is root colonization. Third step, it is growth of fungal gift, and last step, it is mycelium network formation. We know 7 types of mycorrhiza, and very important for our agriculture crops, it is endomycorrhiza, because this type of mycorrhiza work with cells of root system, and we can work with mycorrhizal product on field crops, on vegetable crops and fruit crops. BTU Center Company has mycorrhizal product which call it MycoFriend, and we have liquid and peat forms this product, and we recommend use this preparation for seed treatment, and if you work with system in row, you can use this preparation. You can apply this preparation in a row with application rate for seed treatment will be 1.5 up to 5 liters or kilograms per ton, and for system in row, application rate will be 0.2, 0.3 liters per hectare. About contain of MycoFriend. MycoFriend has all these microorganisms, but bigger part of this preparation is fungi of the genus Glomus. Other microorganisms are in mycofriend. For other microorganisms provide better symbiosis between glomus and root system of our agriculture plants. And we have very often we have a question how to use the dry form of the preparation. We have a YouTube channel where we show video with our practice with usage our preparation, and we recommend several steps for it. First step, it is opening foil packaging. Second step, it is we receive the preparation in vacuum packaging. Third step, it is we provide air access to the bag. Next step, it is blend contents to a smooth powder. Next step, it is distribute evenly across compartments. After it, we start mixing the top layers. Next step, mix the lower layers, and very important process, it is sowing. Please don't forget to sow. About functions and effects of mycofriend. Mycofriend has next functions: active colonization of root and root zone, increased absorption area of the root system of the plant due to the creation and development of mycorrhiza, reducing the number of phytopathogens in the soil, providing plants with vitamins, phytohormones, amino acids. And mycofriend has effects. Next effects, it are providing a balanced mineral nutrition, increased resistance of plants to diseases, improved seed germination, seedlings survival, and increasing crops productivity by 10 up to 20%. mycofriend is on the market from 2017, and we work with this preparation on a little more than 150,000 hectares. This preparation is in 11 countries, and we have a lot of trials with this preparation, and with this preparation with other our biological product, and we have positive results from these trials. Level is 83%. Small our statistics of trials. We use mycofriend for different crops, and it provided us average increase in the yield from 0.2 up to 0.53 tons per hectare. Depends of different crops. A little more about our trials on sunflower. we want to show you several trials in different years. Different years, it means like MyCoRhiza work in different climate conditions. Regions show us about MyCoRhiza work in different soil conditions. Also, we show you different application method, and we use liquid form of MyCoRhiza and pit form, and application rate from 0.1 up to 0.25 liters per hectare, and it provided us increasing the yield from 0.1 up to 0.4 tons per hectare. And I want to draw your attention on these two trials when we compared it efficiency our product with EU analogs, and we showed a little better yield on sunflower. Also, we have a trial in Institute of Steppe Agriculture. We used MyCoRhiza with a rate 5 liters per tons, but we try also we checked different system of system fertilizer system. First type fertilizer system, it was organomineral system, second mineral system, and third without fertilizer. And in these cases, MyCoRhiza provided us increasing the yield from 0.18 up to 0.25 tons per hectare. Next, our trial was in Kharkov region, and we used the liquid form preparation of MyCoRhiza with a rate 0.25 liters per hectare, together with liquid complex fertilizer, which called Diafan 525 with a rate 20 liters per hectare. So I want to say about you can use MyCoRhiza together with liquid complex fertilizers. And in this case, MyCoRhiza provided us the average increase in the yield 0.3 tons per hectare. Other our trial, it is the Sumy region, or Poltava region, and we use also liquid form of MyCoRhiza with a rate 0.2 liters per hectare. And this rate provided us increase in the yield 0.28 tons per hectare. A little more about our trials on corn. Also, the same table on corn. We show you different climate condition, different soil condition, and application methods. For corn, application rate was from 0.1 up to 0.25 liters per hectare, and MyCoRhiza provided us increase in the yield up to 1 ton per hectare on corn. Also, I want to draw your attention on our trial in Germany in 2020. We used a liquid form of mycofriend with a rate 0.1 liter per hectare, and it provided us increase in the yield 0.8 tons per hectare. Also, next to interesting trials, it are trials in Chernihiv region in 2020 and 2021. We used mycofriend pit form with a rate 4 kilograms per ton, and in 2020 it was trial, but when we show in this farm increase in the yield up to 1 ton, they used mycofriend for mycofriend per 10,000 hectares in 2021. On this slide, you can see a photo from trial in Germany, if you remember, in 2020. And increase in the yield was 0.8 tons per hectare. Our fresh trial from Vinnytsia region, we used mycofriend with a rate 0.2 liter per hectare in system infra-row. And I want to draw your attention on yield, control yield. It was 20.1 ton per hectare, but the usage of mycofriend provided us yield, increase in the yield 0.89 tons per hectare. Other our trial, Sumy region. It is Sumy region, and we used mycofriend 4 kilograms per ton, and it was seeds treatment in cedar. And mycofriend provided us increase in the yield 0.8 tons per hectare. You can see on this photo, you can see plants from control field and plants from trial field. On this slide, we can see formation of mycorrhiza, and it are photo under a microscope. As you can see on control photo, mycorrhiza don't formation, and on sunflower is the same situation. When we used mycofriend, we can see good symbiosis between mycorrhiza with root system, the same situation on sunflower. About our trials on cereals, we have the same table, different climate conditions, different soil conditions, different application methods, and application rate of mycofriend was 1 liter per ton, 1.5 liter per ton, and 2 liter per ton. It provided us increase in the yield a little more, up to 1.3 tons per hectare. But I want to draw your attention on these two trials. These trials were in Kyiv region in 2019 and 2020. We used different forms of MyCoRhiza, but we used the same application rate, and it provided us the same similar increase in the yield, up to 0.5 tons per hectare. Also, we have trials from Institute of Steppe Agriculture, and we used MyCoRhiza with a rate 1.5 liters per ton. Also, we have different fertilizers system. It are organomineral, mineral, and without fertilizers system. And in these cases, MyCoRhiza provided us increase in the yield from 0.25 up to 0.62 tons per hectare. Also, we have fresh trial on winter wheat. It was Zhytomyr region. We used pit form of MyCoRhiza with a rate 2 kilograms per ton, and we make the treatment in a seeder. And in this case, MyCoRhiza provided us 0.38 tons per hectare. Also, we have a trial on winter millet, and we use MyCoRhiza with a rate 6 kilograms per ton. And it provided us increase in the yield 0.24 tons per hectare. On this slide, you can see how MyCoRhiza stimulate root system on hemp seed and winter wheat. Sorry. Our trials on soybean. MyCoRhiza has application rate for soybean from 1 up to 2 liters or kilogram per tons. And I want to draw your attention on this trial in 2020, Poltava region. We applied MyCoRhiza on seeds before 1 day to sowing, and it provided us increase in the yield 0.16 tons per hectare. 16, sorry. Also, we checked efficiency on soybean in Institute of Steppe Agriculture, and we used MyCoRhiza with a rate 1.5 liter per tons, together with our preparation, which representative of my colleague Alexander. On control was only Rizoline with Rizosafe, and MyCoRhiza in compared with background phone control, MyCoRhiza provided us increase in the yield up to 0.43 tons per hectare. Again, we have fresh trial on soybean. It was Sumy region, and we used liquid form of MyCoRhiza with a rate 1.5 liters per ton. and it provided us, MycoFriend provided us increase in the yield 0.26 tons per hectare. Trial from Zhytomyr region, when we use MycoFriend with a rate 1 liter per ton. Also in 1 ton mix was optimized. It is inoculant from other company. Also in this ton mix used chemical protection, protect Maximic cell, and on control field was only optimized with Maximic cell. I mean about without MycoFriend. And in this case, MycoFriend provided us increase in the yield 0.8 tons per hectare. Our efficiencies, our trial on soybean from Russia, and on this slide, we want to show you how you can check efficiency of MycoFriend on soybean. For example, you can check it as shown on this slide. I mean about you can to clear root system with grunt from the soil, and you can put root system in water. About our trials on other crops, I want to show you our efficiency study of hazelnut growing by layering, and the use of MycoFriend for different methods of hazelnut layering using sawdust as a substrate. And in these cases, MycoFriend provided us more marketable small plants to sell. On this slide, you can see efficiency study on high blueberry, and we used MycoFriend with a rate 1 liter per hectare in fertigation. And on left photo, you can see root system without MycoFriend. On right photo, you can see root system with gifts of mycorrhiza. Also, you can the same case on gooseberry roots. Left photo without MycoFriend, right photo with MycoFriend. You can see on this photo good symbiosis between glomus and root system of gooseberry. And also we have fresh trial with MycoFriend on potatoes. It was Cherkasy region. We used the MycoFriend with a rate 0.5 liters per hectare, and it was treatment with an applicator during planting. And in this case, MycoFriend provided us increasing the yield up to 1 ton per hectare. And general recommendation of MycoFriend. First, it is treatment of seeds of winter wheat, sunflower, soybean, corn, vegetables, and fruit trees with the preparation mycofriend increases the yield of these crops. The preparation can be used with the rate 1.5 up to 5 liters per ton for pre-sowing seed treatment. If you use pit form of mycofriend, application rate will be 1.5 up to 5 kilograms per ton for seed treatment in a seeder. Also, you can use liquid form with a rate 0.2, 0.3 liters per hectare when you apply mycofriend in a row. The use also we can say about the use of mycofriend at a rate of 1.5 liters per tons steadily increases the yield of winter wheat, sunflower, and corn, regardless of the fertilizer system. The use of mycofriend at a rate of 0 or 1.5 liter per ton can be combined with inoculants for legumes, which increases the yield of legumes. For corn and sunflower, the use of mycofriend when sowing in a row, I mean about system in for row, at a rate of 0.2, 0.3 liters per hectare provides a stable increase in yield, can be combined with other biological preparation and liquid complex fertilizers. And it is and thank you for your attention. If you have questions, you can ask me.
Okay, thank you, Dmitro, for the presentation. And actually, we have one question. Which of fungi of mycofriend set was responsible for mycorrhiza with high boost blueberry? And I think I will comment. So you have seen the content of mycofriend. In it, we have 2 strains of glomus, and also we have trichoderma and some supporting microorganisms. So in case of blueberry, no, we suppose glomus to have mycorrhizal connection with this plant. And also our scientists say that actually trichoderma in some cases also can have a mycorrhiza kind symbiosis of with root. So I hope that I answer your question. Dmitry, and similar to Alex, as we have no much questions now, maybe you can comment some frequently asked questions for mycofriend, maybe for pit and liquid forms usage, when to use what, maybe some others frequently asked questions for mycofriend. You can comment.
Okay, I think one often question it is what forms, liquid or peat, will be better for crops. I think, and I can recommend to use form depends in your situation in farm. If you have протрующую машину.
Seed coating machine.
Yes, yes. You can use liquid form. If you don't have, you can use pit form like I showed on my presentation. But I like a little more maybe a pit form of mycofriend.
Okay, I think it will work with you better. So, and we have another question from Robert. Is it not counterproductive to mix mycorrhiza in place where there is a lot of fertilizers? So, in case there is an intensive scheme, what do you think? Intensive in terms of fertilizers, a lot of fertilizers. Does it make sense to use mycorrhiza?
If I right understood, I think a good answer will be next. We have table with our Robert, don't worry. We have table with compatibility our preparation with a lot of chemical active substances, and also we have laboratory trial with different mineral fertilizers, and mycorrhiza will be on root system in different cases, and rate of mineral fertilizers don't influence on mycorrhiza, if you understand me.
Yes, and I want to add also that actually most of the trials which Dmitry have shown, a lot of them, all of them, I didn't see any from organic schemes. Actually, mycorrhiza is used there too, but the trials we have seen today, like up to 100, are made on the intensive technology. So in most cases, again, it is an intensive technology, means a lot of fertilizers, and we see the positive result. And the important thing is that mycorrhiza is not only the fertilization and nutrients, it's also water absorption, and it is also as an antistressant. So it can help you from some another stories besides nutrition. And second question was about the reaction of mycorrhiza to seeds that are chemically infested. Again, part of the answer will be that all the trials you have seen today on corn or on sunflower, you cannot find any like untreated seeds to use. So on the trials, we see mycorrhiza action on chemical protected seeds. And also we have a table of compatibility, which we share with all of our partners, where you can also check the compatibility with this or that chemical protectant.
I think we have the same situation in Ukraine, and all our maybe 90% our trials also with seeds that are chemical infested.
Yep. And another question is about the reaction. What about reaction of mycorrhiza to organic fertilizers? How they work together? What do you think?
For example, I work in Ukraine. I work with one farm, organic farm, which have 7,000 hectares for organic production, and they use our MycoFriend pit form for seed treatment of corn. With rate 5 kg per ton, and they have the same yield in comparative with, if I right and remember, maybe a product from USA. Maybe yes, USA. Sorry.
Okay, so are there any other questions or ideas, Dmitro? What is asked for mycorrhiza? So we had some questions for mycorrhiza in dry conditions, and we plan to do more trials this season in some difficult regions. Again, in dry conditions, probably dry mycorrhiza could be a better decision. Also, I want to comment that mycorrhiza, MycoFriend is registered in the EU, in Austria, and is being recognized in other EU states, liquid formulation for now. And during next year, this and next, we plan to register a pit formulation as well, because we see that really for some farmers it's more convenient to use it. So if you have any other question, please write it to the chat, and I will summarize our today's webinar. That of course not so much audience today we have, but still we have this webinar. I think it is efficient, and we have the recording, so you can come back to it when you have a need, or when you have, because we have a lot of partners here, when you have new colleagues in your team or new agronomists, you can share this recording with them just to review the material. And as we have now so much people, I want to personally thank to all present, especially those who I know. To sorry if I spell it wrong, to Przemek from Poland, to Jakub, to Georgic, as I understand, a partner from Serbia, from Delta Agrar, to Zoltan from Hungary, to Michel from Cyprus, to Robert and his team in Slovakia, and to Tomasz, our how to say, low and loyal partner farmer in Poland. So thank you again for participants in today's webinar. We will continue this series in a few weeks. We will talk about biostimulants, we will talk about bioprotection, and later on we will talk more about soil health. So again, if you missed our previous webinar about biofertilizers and fertilizers market, you also can find it, the recording, on our Facebook page. And so have a nice end of the week, have a nice start of the season. I wish you good yields, good weather, good conditions, good prices, enough fertilizers, enough biofertilizers, and let's have a, how to say, but the main, as you see, the situation in around Ukraine, I wish all of you peace and development for all years, actually, not only for now. So have a nice day, and goodbye to everybody.